All right, guys, let's take a look at this here. Okay. So, what does percent mean? Say again? A portion, I like it, but what does percent directly mean? Per 100, right? Over 100. So if I had 7 over 100, what percent is that? No, come on, not decimal. What percent is 7 out of 100? 7%. 7 per 100, 7%. The word cent comes from centime, from Roman, all kind of shit, right? That's why we use 100 cents to make a dollar. This breaks the dollar up into 100 parts. Maybe? Maybe. So if the bottom was 100, kick ass, right? What do you got? Deer divided by 100 is deer percent. Whatever the hell, right? So is that first one out of 100? Oh, it's like, what shit are you talking about? Whatever over 100 is that thing percent. Is that first one out of 100? No. Can you make it out of 100? Of course you can, right? Now, of course you could. Since it's a fraction, what else could you do? What's a fraction mean operationally? What's the operation inherent there? Division. Our brain, I think this kind of trips me out. I don't know why people do this so much nowadays. So whoever did this, don't feel like you're alone. That does not say 5 divided by 3, does it? So don't put the 5 inside and the 3 outside. That would be 5/3. This should be less than 1, right? So when you divide this, it better come out to something less than 1. Okay, I like it. So you got 2 ways you could do this. I could make it directly into percent by multiplying by what? Multiply by 20 on the top and bottom. I like it. Which makes 60 out of 100, which is 60%. And of course, what is that as a decimal? 0.6. Oh, shit. You could put 0.60, you'd be fine, right? Tenths, hundredths. How we doing? Okay, maybe. Now, the other way to do this is to go 5 into 3. You got to put a 0.0 there, right? And go 6 times, and that's there. So 0.6, bam. Okay, I like it. One thing about percentages and decimals. The percent number is always bigger than the decimal number. You can see that? 60 is bigger than 0.6. Do we agree with that? Okay. Why is that? Because this one, the symbol means divide by 100, so it hasn't been divided by 100 yet. That's why this is always going to be smaller, because that's what you get after you divide by freaking 100. So you move it twice, because 100 has 2 freaking zeros in it, right? Which way do you move it? Well, here's a nifty way, if what I just said doesn't make sense. Put the letters D and P in alphabetical order. If I'm going from decimal to percent, I move them that way. If I'm going percent to decimal, I move them that way. And it's always twice because it's 100, right? Is everybody with me? So a lot of you guys should be right now going, dude, I freaking know how decimals. That's great. Some of you guys are going, okay, this is good shit. All right. So one thing I want you to know, the backgrounds of people in this class are very different. Right? So if you're surrounded by a bunch of people that just took algebra and aced the shit out of it, and you're like, I took algebra about 10 years ago, so you guys kind of with me? Then don't gauge yourself based on those people, right? It's nice for those people. It's like me when I had to take art. I come to find out I paint decently well, but there were people in that class that had been painting since they were 3, and they were bringing in paintings they had done years ago, and I'm like, that's not fair. I haven't done shit. Well, that's just too bad. Everybody comes in at a different level. You guys with me? A little bit? So don't gauge yourself around other people. So if you have questions, don't stop. Don't not ask them. Please ask them. Right? Other people around you might know, but good for them. So what about this guy? What do I do? How do I change it to a decimal? Yeah, move it this way. Once, twice, so 0.427. What place is that in? Thousandths, right? Tenths, hundredths, thousandths. So you get 427 over 1,000. How we doing? Okay. Hey, there you are. Rune, here you go. We're doing this right now. So this one is going to be the opposite of this one, right? What is that as a fraction? That, of course, is going to be okay, I like it. So as a percentage, once, twice, 6.4%. Now, real quick. What's the percent symbol mean again? Real quick, what's percent? Over 100, right? Per 100. So what's wrong if you say, so as a fraction, this is this? Isn't percent over 100? That's what you said, Jeff. What the shit, Jeff? Come on, math boy. What's wrong with it? What's wrong with that? Why is that not a fraction? There's real numbers in there. There's nothing but real numbers.
100, it's not really the 6.4, because it's just a percent.
Well, that's the decimal, right? So fractions have to be ratios of whole numbers. You guys sent over. There's not a damn thing wrong with doing that as a first step. Anybody know how to clean that up? How do you make the top become a whole number? I love you guys. You're like, I don't flip it, no, dude. Well, what can I do with a fraction? What am I allowed to do with a fraction? I can do the same thing top and bottom. So what thing can I do? I can do what to the top and bottom? Multiply or divide, right? What would I multiply by to make that a whole number? I gotta make the decimal move over once, right? So I multiply by 10. Or even you can just say, if I move that over once, I have to move this over once. So then it becomes 64 over 1,000. Why does that match up with what we should have known anyway? Because, of course, this is in the thousands place, right? That's why it's 64 over 1,000. Holy shit. Math is self-consistent. Oh, my God. If it wasn't, we throw it all out. And we'd still be living in caves, all that kind of stuff. Become a zero. Yes? Oh, so in these kind of problems, I don't care about reducing. It's not math 88, I'm not going to test your ability to reduce. In fact, if I see a reduced number there that sometimes tells me, oh, it was done in the calculator, this kind of problem, I don't want it done in the calculator. So to be honest, I'd rather not be reduced. This one is kind of evil because your brain says, oh, Uncle will do already so tiny, but if I want to change it to a decimal, which way do I move the decimal place? Yeah, that way, right? To the left. So I got to move it once, twice. You guys, everybody with me? You guys are all like, oh, what have I gotten myself into with this shit? So once, twice. So I got to put another zero in there. Right? Yeah, there we go. Cool. Yes, maybe. And again, if you did the little thing we did just a second ago, if you put 0.03 over 100, once, twice, So that's 3 over 10,000. And how does that match with this? Well, this is tenths, hundreds, thousands, 10,000s. 3 10,000s. Okay, maybe. And now this dude, it's over 1. It's bigger than 1. So the percentage is going to be bigger than... If I had 1.12 pumpkin pies, I got more than an entire pie. So therefore, I got more than 100%. And of course, if I just use a rule, what's this become as a percentage? 112%. Why is that fine for a lot of things? Because my salary could increase by 112%, which means it more than double, which I'm not going to hold my breath to happen. Right? So more than 100% makes sense in some situations. If it was a probability, that wouldn't make a damn bit of sense. It's 112% chance of rain. It's going to rain so bad, it's going to be giant drops of rain. Or it's going to rain in the next universe over too. It's 112% chance. What are you talking about? Maybe. So when we get to probabilities, dear God, don't get a frickin' probability greater than 100% and go, yeah, we circle that shit. No, come on. Something went wrong, right? This is fine. You can have 112% amount of money, 112% more puppies, whatever. Puppies out. And what is this as a fraction? There's two ways to do this. What is this as a fraction? 1 and 12 hundredths. I love it. What is this as a fraction? 112 over 100. These are the same thing. How do I make 1 and 12 hundredths become an improper fraction? 100 times 1 plus 12 is 112. Beautiful. So they're the same thing. I like it. Now this one. You got me. So I'll do this in the long way, and then I'll show you a bit of a shortcut. What do you have to do for this guy? Can you make the bottom become 100 easy? Hell no. If you can, show me. Right? You can. No, it's gross. So what do I have to do instead? Do the division, right? So I got to do, run out of here, 16 into 3. I think nowadays our brain says 16 can't go into 3, so it must be the other way around. No. It's 3 divided by 16. That's the only way to write that. You go, that's too bad, brain. It's just not going to work that way. Oh boy, here we go. Now, if you do this, this is a little bit of an exercise in do you remember how long division works? Because I didn't let you use a calculator. Ha ha ha. So 1, 8, 7, 5. Okay, thank God. So 1875. Let me do this real quick. I'm not saying that everybody should get this, but just in case you do, what's 3/4 as a percentage? You should kind of know this. 3/4. 75%, right? It's 3/4, or 75 cents. 75%. You guys with me? What's half of that? That would be half of 3/4 would be 3/8. You guys with me? Is that right? Half of 3/4 would be 3/8. And then I'm going to half it again. You guys. So what's half of 75%? 37.5. If I half that one more time, I get 18.75%, and there I am. Now, if you don't like what I just did, you don't have to do it, right? No. But just in case you kind of get what I just said, it's actually kind of a useful tool in a few different places. Okay, I like it, maybe. Okay. So what is that as a percentage? I already gave it away. 18.75%. Okay, I like it. Some guys might have given up early on the long division and just said 18. No, if I don't say round, you keep going. All right, what about this guy? This is another one. Number 2 is infamous for people saying 20 over 3, which is like you're neat. You're creating people. And yes, if you had 3 people, and at least one of them is a different sex, give them enough time, you can make 20 people. But that's not what I'm trying to do here. You can't say 20 out of 3. That's neat. There's 3 people. How many of them like this? 20. So this is 3 divided by 20. And then it becomes a problem like that first one, because the bottom can become 100 easy, right? 3 out of 20, which is what out of 100? 15. I like it. Okay. I like it. Now again, just to remind you guys, some of you guys are like, what the shit are we doing? This is easy. Some of you guys are like, oh my God, slow down, what the hell? This is stuff that should be kind of easy. And if it isn't, you might want to come see me and get some extra practice. I'm not trying to make you feel bad. I'm trying to make you realize this is the kind of stuff that you're going to have to be able to do, because what's statistics and probability all about? Percentages. Holy shit. So we got to know how they work. Then, of course, I give you some beautiful algebra, right? I might be the only one in here that it would describe it that way. But how do you solve this sucker for x? What do you have to do first? What's the worst thing about this problem besides it exists? What's the worst thing about this thing? Huh? It's a fraction. Damn thing. So thankfully in an equation I can kill fractions. It always feels nice. So the first thing I want to do here is multiply by s. Die! Right? Get a little aggression out. So I get sz equals x minus m. Both of these equations, by the way, are equations we're going to use this semester. We don't currently know what they mean yet, unless you've taken some statistics. This letter, by the way, is not going to be an M. It's going to be a Greek letter, but I didn't want to put Greek on here yet and freak you the shit out yet. I'm going to freak you the shit out later. And then one last step. Add M. So I get x equals sz plus m, or any rearrangement of that. I like it. What's order operations, by the way? Please excuse my dumbass son, or Giron Sally. Or one class. This is the class, not me. The class came up with this. Please excuse my deficient algebra skills. Right? You guys remember PEMDAS? Okay. And multiplication does not come before division. They both are at the same level. You guys remember that shit? And I'm so sick on the freaking Facebook. And I know a lot of you guys don't use Facebook, which is great. Maybe some of you guys still do. But, you know, if you're not into Facebook, don't get into Facebook because they don't have you. They have me. Shit. But I see so many freaking people posting these, can you do this problem? And the order operations. Oh my God. It's like just freaking basic order operations. Dear God. Sorry. I'll stop. Now this number 4 has a very similar problem that this did, but what's wrong with the n? There's two things wrong with the n. And what do I mean by wrong with it? There's two reasons why it's not by itself. It's on the bottom and it's inside of a... So I know what I need to do. How do I make it not be in the bottom anymore? Multiply by it. So I get square root of n times e equals zs. Bam. All right. Is the n thing by itself yet? How do we get, what do I need to get rid of? Stupid e, dude. And then the last thing I have to do is what? Say again? Sorry?
Get rid of the square root.
Yes. And by doing, how do I do that? Square both sides. Kick ass. So later this semester, I'm going to point to this problem because we're going to do this whole thing again in chapter 8, I think. Yes, maybe. All right. Everybody okay? Somewhat. All right. So what about this one? This one, I want to show you a neat little trick because I think everybody pretty much knows how to find the average. How do you find the average? Add them all up. Divide by how many there are. I like it. So 5. Kick ass. Here's a beautiful way to divide by 5. Not setting up stupid long division, right? Nothing wrong with long division, but I don't need it here. If I double the top and bottom, I get that. Yes? And how do I divide by 10? With the decimal back ones, right? So dividing by 5 is easy as shit. You double the top, move the decimal back. See, there's a good thing about knowing how to work with numbers. We have to work with numbers every day in some way. And if we knew how to manipulate them quicker, that would be quicker and easier. We wouldn't make mistakes. Okay. Anybody a waiter or waitress or has been before? What's the worst thing? What's nice for you but bad for me as a math teacher is most places now have the tip at the bottom. Which sucks for math teachers. That was one of the few places people had to practice their math. But what's bad for waiters and waitresses, people wouldn't do their math. They would just guess and guess really low, right? $5 on 180 sounds about right. Get out of here. Right? Anyway, sorry. What about this one? I'm going to do this one two different ways. I'm going to do it the classic way, which is the suggestion I gave to a few of you guys. Algebra saves our ass when there's something I don't know, but I know the end. Algebra is all about working backwards, right? Like the crazy dude that didn't know how much money he put in the bank. Who the shit is this? I don't know how much money I put in there, but I made $180 in interest. Can you help me? I want that problem. Did I put 10,000 or 20,000? Oh, holy shit. Oh, statistics?
Yeah, Salvador.
Oh, okay. Grab a seat and see me after. Oh, here. Get a copy of this. And then see me after. We're doing this right now. We're on the last one. So one way to do this is to say the third grade is X. And then algebra says, now do everything like you would. That actually is really beautiful if you think about it. It's like, I want to do that. Well, algebra goes, now you can. Well, how do you find the average? Add them all up. Divided by how many there are. You should get the average, and we know the average is 80. Now let me ask you this. Why is this next thing going to make sense? If I know that three numbers average to be 80, what do they have to add up to be? 240, because what do you divide by 3 to get 80? 240. So the next step, 3 times 80 is 240. So that I know they have to add to be 240. And that's what the next step of the algebra does for us. It goes, oh shit, look. Maybe. You guys doing all right? That's not a third power. It's a die. So then they get 81 and 72 is 153. Oh, I lost my X. And of course, the last step is subtract 153, and you get good try. 87. That's all right. You can set the table if you want to. Nobody's there, yeah. You got the nice. You're good. Come in late, but you get a nice table. Don't get used to that shit. All right. Let me show you another way to do this. And I'm not trying to prove to you that algebra is always unnecessary. I'm just trying to prove to you that algebra is one tool that is sometimes the best tool. Believe it or not. But here, there's an interesting way to do this. 81, 72, and something. Right? 3 grades. How far away from 80 is this? 1 up. How far away from 80 is this? 8 down. So how far away from 80 am I total right now? 7 down. So this one better be 7 up to make the average come out to be 80. Now if you think about it, all I just did, what's the average of 5, 5, 5? Holy shit. What's the average of 4, 5, 6? Still 5, because I took 1 away from 4, gave 1 to 5, so of course they all added to be the same stupid thing. Yeah. So I'm just seeing how much off are they all, so I can figure out how much off the last one has to be to fill in, or to take away whatever is extra or missing. You guys kind of see what I'm saying?
I get you.
So numbers are freaking cool as hell. There is a reason to know how they work, so that when I hit them, I can use them quicker. Right? That's all there is to it. On that same note, before I get into pure statistics, I always like to tell any math class this. Do you guys know how to check? Some of you guys might know how to check if a number is divisible by 3. You should know if a number is divisible by 2. Dear God, if you don't know that, maybe you don't even tell me. It's going to make me cry. But if it's even, it's divisible. What about 3? How do you know if a number is divisible by 3? Does anybody know? You're like, yeah, put in the calculator. It comes out to a whole number. No. Just looking at a number, how can I tell? Anybody know?
Is it when you add up the numbers?
Yeah, somebody, yeah. If you add up all the digits and it comes out to be divisible by 3, then the whole thing is. So the number 111, 1 plus 1 plus 1 is 3, is divisible by 3. Did anybody know that before I just told you this? It used to be something everybody knew. And now nobody freaking knows it. Which is bullshit. You should be a little angry. Why did they never tell me this? Who gives a shit about calculator? You should just know how numbers kind of work. What about 4? Anybody know about 4? How do you tell if a whole number is divisible by 4?
No.
No, I like it. The dude's like, I got you. No. Right, supposed to. if the last two digits are divisible by 4. So the number, this number, you ready? This number, that number right there is divisible by 4. Why? Because that is. Why is that true, Jeff? Because 4 goes into 100, doesn't it? 4 quarters makes 100. So 4 goes into 100, therefore 4 goes into 200, 4 goes into 300, 4 goes into anything 100. So if 4 goes into 800, doesn't 4 go into 804? So if the last two digits are divisible by 4, the whole thing is. Are you guys semi with me? 5 you should know, dear God, right? What about 6?
No.
6 is what times what? I want somebody to go 1 times 6, Joe. So it's 2 times 3. So if the number's even and 3 goes into it, therefore 6 has 2. Because if it's even, 2 goes in, and if 3 goes in, then both of them go in, so 6 goes in. Holy shit, you guys, maybe too much. I'll stop there. But these are things that you should be upset about a little bit if you've never heard that at all. You should be a little upset. Okay, we're going to do a little bit of actual statistics. We're going to get into the first chapter. And the first chapter, just to warn you guys, I think I said this over the email. You should, hopefully some of you guys have gotten into it. I know at least one of you guys have gotten into it. Holy crappity do now. All right, phone, don't go anywhere. All right. Well, got Gorilla Glass. I don't have one of those cheap little iPhones, sir. What do you mean cheap? Yeah, it costs a lot of money, but it dies quick. All right. That'll work. So, you guys help me out here. Actually, I tell you what. There's one more thing I want to do. Can you guys take a blank sheet of paper for me? I want to do this right now because this is the day that I'm going to have the most people in this room. And this is when this works the best. Get a blank piece of paper and write, like I was born September 21st. Anybody else born September 21st? Is that surprising to you that I'm the only one born September 21st? Wait. Don't get what I did. Somebody came in with knowledge already. Stop having knowledge. No, that's good. I'm going to write 2-1 really big so that you guys can all see 21, right? You wouldn't even look at 11. I can see it. Well, no, with your eyeballs, not with your ears. Okay, so do that favor for me. If you were born on March 11th, put 1-1. Anybody born March 11th? That would freak me out. Woo-hoo. No, okay. Everybody understand what's happening? If you were born December 12th, put 1-2 on a piece of paper, nice and big, so I could see it with my one good eye. Don't show it to me yet. I love it. Everybody got that? That shouldn't be too taxing, I hope. Okay. What do you think are the odds? What do you think are the chances? Do you think there are good chances that two people in here have the same birthday? Some of you guys are saying yeah?
Yeah.
Okay, I like this. So more people know this. So like my man over there was about to say, I think it's once you get about 34 in a room, you get a greater than 50% chance. And I have 46 or 47 in here. So I would put money, and being a teacher, this is huge. I would put money on two people having the same birthday. Where are my January babies? Raise your numbers. 3rd, 30th, 27th. Oh, what's that, 7th? Darn it, I was excited for the 13th. So close. All right, February babies. 15th, 16th, dude. All right. 16th, no, 26th. Oh, so close. February, March babies. March 18th, 23rd. Okay, January, March, April. 12th.
Oh.
9th.
5. It's a 5.
It's going to be interesting semester. 12th, 9th, sorry. 12th! Dude, we got it. We got birthday twins. How about that?
Yeah.
All right, let's see how many we get. Where am I at? April, May. May? Yeah, screw me. Oh, she's got May to herself. I like it. May 24th. May, June. 23rd, 26th, 12th, 21st, 12th. There's another 2nd, 4th, 19th. I didn't say 4, did I? No. Okay. So I got 2 now, right? 2 pairs of birthday twins. July. Okay, now it makes sense because 9 months before this it was cold. Let's see. 15th. Some of you guys got it. 29th, 21st, 7th. Okay. July, August. 26th, 24th, 7th, 27th. So close, man. September, my bad. So 21, 4, 11, 17. October. 14, 26, 18, 27. So close. November. 6th, 2nd, 9th, 12th. December. 14th, 18th, dude, all right, that's 3. Is that 8? Oh, man, I saw the red line. So close. 22nd. Okay, so we got 2 pairs. I think the most pairs I ever had was 5. And if I ever have twins, I discount them from the beginning because that's a little bit of a cheat, right? So I've had twins a few times. I'm like, well, you guys just don't count for this at the moment. But the most I've had 5. One semester I had none. I was so bummed out, but the probability doesn't guarantee it. It's just a very high chance. Okay, sorry. I just wanted to do that before I forgot. Oh, thanks, man. So, we're going to do just a little bit. And the first chapter is definitions, which, again, adds to the excitement of the day, starting with talking about the syllabus, ending with definitions. Can you guys... Is there anything you're interested in about like gross fund students? Like, for example, the percentage of gross fund students that go to Ocean Beach or something, right? Is there anything like that or more interesting than that that you're curious about? Like the average age of gross fund students or something like that? Anybody interested in all about anybody? Or you're like, no, dude, you should just be happy I'm here right now? Anybody have any interest about anything about your fellow students? Oh, sweet. Okay, 11. You're perfect. Thank you for playing. So the percentage who have been overseas.